Okay, so we'll be starting. We'll be starting the session now. Uh, in this session, I will be solving the questions for week one and two, and then I will be teaching you. Uh, then I will be teaching you Google Earth Engine. So for every question, I will be giving you 2 minutes to solve if it is numerical, and 30 seconds if it is theoretical question. So we will start now. For first question, now you can take 2 minutes. This was week one assignment one. So question is, a man moving on a circular path covers 0.4 pi radians in 6 seconds. What is his angular frequency? So now you can take 2 minutes, then I will start solving. So this is the first question. 2 minutes you can take, then I will start solving the question. Okay, so now I will solve the question. So a man moves 0.4 pi in 6 seconds. So what will be its angular frequency? So 0.4 pi means this is total 2 pi. So someone has moved 0.4 pi in 6 seconds. So what will be its angular frequency? So directly we can, that is displacement 0.45, 4 pi is displacement, angular displacement, and 6 second is time. So if we solve this, this will be 2 pi by 30 or pi by 15 radian per second. So you can take 2 minutes to understand. Then I will start with next question. Uh, oh, okay. You are not able to see the screen. Okay, okay. 1 minute. Uh, I guess now it is visible. Now it is visible, right? Okay. I will explain once again because the screen was not. So, question was a man covers 0.45 radian 0.4 pi radian in 6 seconds. So, what is his angular frequency? So, this is angular displacement, that is 0.4 pi, and this is time. So, for angular frequency, we will just divide displacement by time, that is we are getting pi by 15 radian per second. So 2 minutes you take, then I will go to next question. Okay, so we will go to next question. So this is microwave frequency bands. So if you can solve this question, I will give 30 seconds as this is only theoretical question. Okay, so I will start. So this is direct question where you know that L band has 15 to 30 centimeter. So you can see there is only one option in between, which is 18 centimeter. So 2, this is 18 centimeter, that is D. Then C band. C band is 4 to 8 gigahertz or 3.75 to 7.5 centimeter. C band. So there is only one option in between, that is 5 centimeter. So this answer will be C. So one answer is C, second answer is D. If we see there is only one option, and other things also, you if you will see, it will be X band and P band also will be in given range. That is X band is 25 to 37.5 centimeter or 12 to 18 gigahertz. And similarly, P band will be P, P band will be in in the range, that is fourth option is B, 45 centimeter. So there is only one option. You take 30 seconds, then I will go to next question. Okay. So moving to third question. If you see what is the question is, what will be the frequency of an electromagnetic wave of wavelength 3 centimeter? So you take 2 minutes to solve, then I will be solving it. Okay, so now I will start solving. So we are asked about frequency when wavelength is given. Wavelength is 3 centimeter and C is constant, that is 3 into 10 to power 8 meter per second speed of light. So if you remember, mu equal to C by lambda, that is the formula, where if you remember, C equal to mu into lambda we can write. Why I am telling? This is meter wavelength and mu is 1 by second, and you can match the unit. This is meter per second. Just to confirm the formula what you are remembering is correct or not. So C mu equal to C by lambda. Here C is given 3 into 10 to the power 8 meter per second, and lambda is 3 centimeter. So that we will convert. So we'll get 10 to power 10 meter. Oh, okay. 1 by second. That is hertz. So we are getting 10 to power 10 hertz. And answer we are being asked in gigahertz. So 1 gigahertz is equal to 10 to power 9 hertz. So we are getting 10 gigahertz. Okay, so you take 2 minutes, then I will go for next question. If you have any doubt, you can ask me. Okay, so I guess there is no doubt. So I will go to next question. So what does radar stand for? So take 15 seconds as this is only full form. Then I will say you. So radar is radio detection and ranging. So fourth answer is C. Okay. So we will move to next question. Okay. So you take 2 minutes for this question. So what is the question is what will be the energy of an electromagnetic wave of wavelength 6.626 picometer, where you have been given 1 picometer is equal to 1 into 10 to the minus 12 meter. Okay, so now I will start. So you have been asked about energy. So energy is given by E equal to h mu. So where h is Planck constant, that is 6.626 into 10 to the power minus 34. And here, as you have been given in wavelength, so you can change this. Mu is equal to c by lambda. So E equal to hc by lambda, where h value will put, then c is 3 into 10 to the power 8 by lambda. We will convert it into meter, all so that all are in SI units. So this, so 10 to power minus, okay, okay, so we are not, okay, so answer is not there in option. Okay, so we will check this later, and we'll move to next question. So the question, you take 2 minutes, then I will start. What is the solid angle subtended by hemisphere at center? Okay, so I will explain. So question is, what is the solid angle subtended by hemisphere at center? So if you see, this will be direct question because hemisphere substance 2 pi steradian at center. That is one whole circle. If it would have been full sphere instead of hemisphere, then full full sphere substance 4 pi. So this is just half of that 2 pi. So then we will move to next question, and I will give you 2 minutes for that, which is the wave function with a time period of 2 pi seconds, an initial phase of pi by 3, and amplitude of 50 meter can be represented by which of the following relation? So if you remember wave equation, then you will be able to do it. So take 2 minutes, then I will start. One minute. One minute. Okay. So 2 minutes is over. Now I will solve it. So initial phase is given as pi by 3. So uh, that you have to add. So either answer can be this or this. And if you see amplitude is given as 50 meter. So that is also in this two equation only. And k is k wave equation is a sine kz minus omega t and then initial. So k is 2 pi by lambda and omega is here time period is 2 pi. So here we will change that and you will be getting answer as omega is it is given time period is 2 pi, so omega you will get 1 by t, that is 2 pi by 2 pi. 1 minute. So you will be getting answer A. Now for 8 question you take 2 minutes, then I will be solving it. Okay, so I will just start solving it. So in this question, it is telling 6 micrometer is dominant wavelength and A, it is telling to assume 2898 micrometer Kelvin. So if you remember, there is one formula uh, where winds displacement law. So there we get dominant wavelength and we can find temperature. So and another 1 minute, someone is joining. Okay, so la- we will get T from there, that is we will divide it, so it comes 24 483 Kelvin. Now if you remember Stephen Boltzmann law, that is sigma T power 4, where this is constant. So we are finding total radiant existence, that is given by Stephen Boltzmann law, where sigma is constant. So 1 minute, someone is joining. Okay. So we will put sigma, that is 5.67 into 10 to the power minus 8, and temperature we have got 483. So 483 power 4. So that we will get answer, that will be, if you will calculate, then we will get from the option A. Exact value, I will say it will be approx 3.09 into 10 to the power 3. Okay, so you two take 2 minutes, then I will go for next question. Okay, so we'll go to next question. So this is based on Python. So you take 2 minutes, then I will say you. Okay. So I will explain you, and I will explain at last in Google Colab also in Python. I will type this, and then you can see. So here what we are giving is D is equal to 20.1, and then we are asking type of D. So if you know, Python is case sensitive. By case sensitive, what we mean is if you write a small d and capital D, both are different in Python. So as we have not defined this D, what we will get in the option is name D is not defined. We'll be getting this, and syntax is valid. So this can't be the answer, and integer also will not come. And if we would have asked this type a small d, then we would have got float. So you can try this in Python by trying this too. Then you will be able to understand. Then we will go for next question. You take 2 minutes. Then we'll go for next question. You can try in collab. I will also see if I can open and show you. So, the- I will share my screen, and I am also typing in collab. After that, I will share with you. Okay, so I will share my another screen. Wait for a second. Okay, so okay, so I guess you are able to see my collab interface. Now I will. So you can see I have typed the small d is equal to 20.1, and then we are giving type d command. So as I have told you, it is a case sensitive. So name d is not defined, and that is what we are getting as error. And when we type d, then we are getting as float, as this 20.1 is stored like float. And then going for next question, that is 10th question, that also is in Python. I will show you, then I will explain you. I will show you first in collab, then I will explain you. 1 minute. So wait for, I will just type. So what is the question is satellite is equal to, we are defining one array here where we are storing some names, that is Modi's, Sentinel and Lancet. So I will, since I'm not putting all things now, Modi's, Sentinel, Lancet. And then short. So I have stored all these in array. Now we have been asked satellites minus 1 what it will give. So we will take this and so you can see output is short. Now why means I will close my this window and I will go in PPT and I will explain you. So now again my PPT screen should be visible. Okay. So what happened in first question I explained you. Now in this question what is happening? We are storing in satellite, we are storing this satellite names, and if we see in Python it starts, if we are going for positive like satellites, it doesn't start from 1, it starts from 0. So this is 0. If you will type this then you will get Modi's as output. And when you start backwards, that is minus, it starts from 1. So this is minus 1, this is minus 2, like that. So that is why we are getting output as short. Now this was week 1. Now we will start with week 2. So you take 2 minutes, then I will start explaining this question. So question is, if a body has reflectivity of zero point 0.6 and power incident on it is 50 watt, which of the following can be the values of transmitted and absorbed energy? So you take 2 minutes, then I will explain you the answer. So generally, in every week, we will be solving only 1 week assignment. But this time there was 2 week because both deadlines were together for you last time, Wednesday. So this time we have two to solve. From other time it will be one. So we will be getting more time in Google Earth Engine if you want to learn. This time we are giving more time for assignment. From next time it will become half of, I guess. Okay, so I will start. So let's assume this is a body. Now anything which is energy is suppose incident upon it, then what happens? Some part is absorbed, some part is reflected, and this is reflected part, and some part is transmitted to other body which is in contact, whichever medium. So here power incident was 50, 50 watt is incident, and it is telling that reflectivity is zero point 0.6. So whatever power is incident, zero point 0.6 of that is reflected. So if we calculate reflected, then it will be 50 into zero point 0.6. So that is 30 watt. Now, as you would have read, reflecting plus absorbed plus transmitted will be equal to incident. So if we take it this one, then other three summation will be 1. So here it is 50. So now remaining is 50 minus 30, that is 20. So 20 watt will be transmitted plus absorbed. So if we calculate first, then it is coming as 15 watt if you add this transmitted and absorbed. Similarly, in B, if you add transmitted and absorbed, it is coming as 30 watt. In C, it is coming as 20 watt, and D, it is coming as 15 watt. So as you can see, there is only one option available which gives you 20 watt. So only there was the question which of the following can be. Means it is not sure this only will happen, but which of the following has only possibility to be an answer. So here suppose it would have been multiple choice, means not one answer, more than one answer, and whichever option would have, suppose this would have been one option, then you would have corrected this also, like C and E will be answer, like that. Means whichever will give you 20 value, that will be the answer. So you take 2 minutes, then I will start explaining next question. Okay, so we'll go to next question. So you try to recall which type of scattering occurs when. Then I will give you 2 minutes. Then I will explain this. 1 minute. Someone needs to know. So if you remember, when uh, target size is much smaller than wave wavelength of interactive medium, that is, target size is much smaller than wavelength of interactive medium, then Rayleigh scattering occurs. Similarly, you can remember what are the, and there is nothing called Planck scattering, or just view this two, and you have to remember if it is much smaller, then it is Rayleigh scattering. So now we'll go to third question. I will give you 2 minutes for this. Like, then I will start explaining. So question is, what is the total distance traveled by a pulse of frequency 3 microsecond from the antenna to target and back? Where you have to assume c is equal to 3 into 10 power 8 meter per second. Yeah. So what is your question? Hello. Uh, can you tell me what is your question? You have raised your hand. Okay, I guess there was no question. So I will start explaining. Third question. So here they are telling total distance traveled by a pulse of frequency 3 microsecond from the antenna to target and back. So what they are giving you is tau 3 microsecond. So if you remember, range formula is C into tau by 2. But what happens there? Suppose this is Earth and here satellite is there, then it goes here that we call as range. But here what has been told, what will be the distance? It covers back also. So formula will change to C tau. So if you see 3 into 10 to power 8 into 3 into 10 to power 6 minus 6 meter. So that is 9 into 100. So total is 900 meter. Take 2 minutes, then I will start with next question. Okay, so now we will go for next question. So that is fourth question. So you take 2 minutes, then I will explain you. Okay, so now I will explain you. So if you see, we denote this is real and this is imaginary, and here it is telling star images A and this is B. So if you see, this is theta, or here we are calling this as phi. So this is A. So tan phi is perpendicular by base. So phi will be equal to tan inverse A by B. So you take 2 minutes, then I will explain, and then we will go for next question. Okay, so we will go for next question. So a, a pixel in a star image looks like 9 plus 5i. Calculate its phase phi in degrees. So take 2 minutes, then I will answer. Okay, so now I will turn same as last question. If you see, this is real, this is imaginary. So this is 9 as per given, because 9 plus 5i is given. So this is 9 uh, and this is 5. So somewhere here 9 and 5i, and we have to calculate this. So tan phi equal to 5 by 9, that 5 equal 5 is equal to tan inverse 5 by 9. So calculate this, then I will say first in radian you calculate. So it will come 0.507 radian, and we will convert it to degree, then we will get 29.05. So answer will be 28.9 to 20, this one B. So take some time, then I will go for next question. Then after 5 question, we'll go little for Google Earth Engine. There are 5 things which I will teach you today in Google Earth Engine. Very basic. Okay, so now next question. So in the figure shown below, what are this first, second, and third? So take some time, then I will say you answer. Okay, so if you see, third is that point exact below is always called as nadir. So third is nadir. So these two are not the option. And if you see, this is we call as look angle, and this we call as incidence. So look angle, incidence angle, and nadir. So answer will be C. So take some time, then I will go for next question. Just 10-15 seconds. Okay. So we'll move to seventh question. So calculate range resolution of a synthetic aperture radar if the pulse width is 3 microsecond. Assume C is equal to 3 into 10 power 8 meter per second. So take 2 minutes, then I will go for explaining. Okay. So now I will explain. So if you remember, one more time we have discussed range. One minute. Range resolution is equal to R, means R equal to C into tau by 2. So here tau, that is pulse width, that is given as 3 microseconds. So C is 3 into 10 to the power 8 meter per second into tau is 3 into 10 to the power minus 6 and by 2. So that is giving you 900 by 2, that is equal to 450 meters. So here answer is A. So take 2 minutes, then we'll move to next question. Okay, so now I will go to next question. So see this, then I will explain you. This is just theoretical question. If you remember, So as this is theoretical question, so now I will explain this. So if you remember here, answer will be 2, and why I will tell you, because SAR, if you see, best possible resolution which can be achieved by SAR when length of antenna equal to length of antenna. Opposite statement has been used, like azimuth, best possible azimuth resolution is length of antenna by 2. So here we have asked when what will be the, so it will go here and answer will be 2. Okay, so now we will go to next question. Okay, so this figure has came there. I will just tell it. It is MCQ from. uh, So match the following. So this is just formula based question. So I will just tell you the answer. And so normalized radar question cross section is first is D. This is just, if you will refer to video, then you will be able to get. Then second will be is equal to A. Third third will be B, and fourth will be C. Just refer to video and you will be able to solve it. Then this is the last question. So just solve it. Then I will tell you answer. Take 2 minutes. Okay. So I will tell you one formula. If you remember, PS is equal to PT into G into sigma by 4 pi r square. So this is area intercepted by radar. G is gain, and power transmitted and power backscattered, PSPT. PT. So, what is given in question to you is, 2 pi r square. 2 pi r square is equal to 4 pi r square. 4 pi r square is equal to 4 pi r square. So what is given in question to you is, 2 pi r square is equal to 4 pi r square. 4 pi r square is equal to 4 pi r square. 4 pi r square is equal to 4 pi r square. 4 pi r square is equal to 4 pi r square. 4 pi r square is equal to 4 pi r square. 4 pi r square is equal to 4 pi r square. 4 pi r square is equal to 4 pi r square. 4 pi r square is equal to 4 pi r square. 4 pi r square is equal to 4 pi r square. 4 pi r square is equal to 4 pi r square. 4 pi r square is equal to 4 pi r square. 4 pi r square is equal to 4 pi r square. 4 pi r square is equal If power backscattered by antenna, so PS, is 25% of power transmitted. So PS by PT is equal to 1 by 4, that is given in question. So 1 by 4 equal to, this is just nothing, G into sigma by 4 pi r square. And also given is, assume the proportional area anticipated by target is half the area of a sphere. So this is a sphere area and it is telling half. So this. So G will be equal to 1 by 2. So answer will be B. Take 2 minutes, then we will start with Google Earth Engine. I will tell you after 2 minutes what all I am going to teach today.
Hi Nitish, can you explain once more?
This question, okay.
Yeah.
So, so we have the formula power backscattered equal to power transmitted into gain into area intercepted by radar. Okay. So here in question it is given if power backscattered by antenna is 25% of power transmitted. So what is given in question is PS is 25% of power transmitted. So PS by PT equal to 1 by 4, that is given in question. Also it is giving assuming the proportional area intercepted by target is half the area of a sphere with radius equal to range r. So this is also given sigma by 4 pi r square is given as in question 1 by 2. So now we have PS by PT will bring this side. So that will become 1 by 4 equal to G into half. So G we will antenna gain is asked in question and that we will get as half. So this,
Okay, thank you.
okay. So now we will uh, go for Google Earth Engine. I will just tell you. So today what we will be learning is this five things, very small things only. We will learn very slowly, and like this time we have got less time because we had to solve two assignments. Now from next time only one assignment solution will be there. So we will divide time equally as one person requested last time to increase this time. Google Earth Engine. So I will be doing that. From next time it will be half of. So today first we will be learning to add open one image or image collection. So this is just opening, and when we will learning last point like fifth point, then we will learn to visualize it. So this will come, means this will go together, first and fifth. Then like in image, there like Landsat image takes every 16 days. Uh, Also Sentinel every 5 days or 6 days. So we will get many range, like if you want to select. So on what means filtering those images for only which year you want or which dates specifically you want or any range specifically you want, that we will be also learning. Then third will be filtering based on cloud cover or any other metadata. So as third procedure is same, we will be learning for cloud cover and similar processes for any other. Now and then this image whole will be seen. So just your place, like your region of interest, we will be seeing how to clip it for only your region of interest, and how to give this that as region of interest also. And then we will be learning to add these, means any collection of image or any image to add on map to visualize it. So these five things we'll be seeing today. It is one line code only, so it will not take much time. So I have copied it. So how we will declare? Like we have to store it in our own variable. So we have in microwave we have to first declare that. The means microwave not in Google Earth Engine. First we have to declare which variable we store. So I'm just giving variable image collection. What is happening? Image collection, one variable is there where we are giving this collection which I copied. Any data which you want to add, just search for that data, and you will be able to see there will be one image collection code there. like I will show you again. Browse data catalog, then just go for any sentinel or any other data which you require, and then click on Sentinel-2 multispectral instrument, and here surface reflectors as I am taking that, and here there will be like where this collection is defined. So just copy it, this whole part, and you will be able to see it here by pasting. Then variable image collection, and let's print that image collection to see what we are getting. So whichever variable we have defined here, let's just copy. So we have defined image collection as variable. So we are just copying, and now just click on run. So it will take some time as we are adding whole collection. Okay. So what is happening is collection query aborted after accumulating over 5,000 elements. So as we have given whole area, like whole world as area, because we are not defining any area and we are giving whole. So it has all images of world, and every 5 days image is taken. So we are getting more than 5,000 numbers of image. So it is not able to process that, and so it is giving error. Means more than 5,000 images are there. You can imagine how much. If you would have opened in QGIS one image, only one image would have been there, or a snap also. Here 5,000 images are there. So Google Earth Engine process data very fast, but 5,000 is too much. So that is why we require to filter according to our own interest. So now let's see, means how we will filter this data. First, let's just see what is there in data. So band 1 aerosol band is there, band 2 blue, green, red, these all bands are there in data. And if you see later, okay, so this data don't have. Okay, image properties, cloudy pixel is there. Okay, so we can filter. So if you see here, cloudy pixel percentage is one image property. So whenever you open any data, you will have three things here like bands, image properties, and terms of use. So bands, you can see information like temperature band is there, or blue band is there, or green band is there, red band is there, or microwave bands are there. So those information will be there. So by band also we can select, that we will see in some other class. For now, we will just filter metadata. And how we can give geometry like region of interest by our own. Now, like first, let's filter data uh, according to our region of interest. So I will give here dot. Okay, first we have to define geometry. So for that, what we have to do, we will zoom our map portion, this, and we will select some small area. Like for now, let's select Mumbai. In that, here five toolbars are there. So for now, I am selecting rectangle. Then you will see one geometry pop-up is there, and here one geometry variable has came in import section. Now I am just going to select one area. So this is what I have selected, and what has happened in this, it has came variable geometry, and this coordinates has been stored here in variable geometry. So now just I can exit from here, and now I have geometry here. So in geometry, what is happening? Like I told you, any variable we have to create, then we have to define first. So this is interface they have made. So we are selecting any area, then we are getting this geometry predefined. Now what I can do here is dot clip. So you can see dot clip, and I will give geometry. So this should be same. As it is case sensitive, you have to write exactly same. So dot geometry if we give, and then we run, again we may get more than 5,000 elements. Okay, we are getting dot clip is not a function. So what is happening is, this is one, uh, I will show you. So some functions are there which run specifically on images, and some functions are there which specifically runs on image collection. What image is one image only, and image collection is set of images there. So clip function works with image, and filter bounds work with image collection. So that is the difference. So now what has happened, earlier whole world data was there, and now it has been cropped only for this geometry, and this is also one image collection. As you can see, I have printed image collection, so we have got results. Now we will see in feature there are 600 elements. So if you see, it has all the bands like from 2018, every time data whenever it would have been taken, it has all the data. These are the dates when data has been taken. So from 2018 till now, whenever was the start date, you can see it will be here. So 28/3/2017, from this data has been started, and end date is going till now like 13 to 22. It is going on. So all that data, whenever this satellite had passed through this Moreland West, that has been given here. So now we have 600 images for this reason. Now you can see, if first data, that is from 1412, and second is also 1412. So maybe two region, two images will be covering this region, so it is coming twice. So what we can do now is, we have to by filter date also. So now let's take, or first let's filter by cloud. So in image properties, if we go, it is written as name is cloudy pixel percentage. So we will copy this, because exactly same we have to write, and we'll give dot filter meta metadata, and comma less than. So actually we should not write like this, because when you will and how to decide how to write is, when you will give here filter metadata in image collection, then you see how they are giving exactly same way you have to write. So we have to give like name of a property to filter, so that is cloudy pixel percentage, we have written that, and they are telling to give it as a string, so we have to give it as a string. And then if you see, we have to write less than like this, one underscore should be there, and it should be in inverted comma. So less than, and then we should give the value, and then we can give run. So earlier, if you would have been seeing, it was 600 elements were there. Now if you see, only 293 bands are there, 293 images are there, and that is because we have given cloudy pixel percentage is less than 20. So only those images which has cloud less than 20 has been taken here, and so we are getting this much less, means it is reduced than half. Now just for more clarity, just make it 10, and you see how fast it is processing, means this much fast you are getting your images. Now I have given 10, so you see more will be reduced. Okay, so we can make it anything, and let's, means any like this, any metadata you have, just write dot filter metadata, and cloudy pixel percentage we have to specify, and then we will be getting. Okay, so that, now any image property you can take like that, and we have to filter by date. So what we can give is dot, because your defined date only you want, so dot filter date, and what you have to do, in single quote you just give date. So date, first what you will be giving is uh, year. So let's take from 2021, 1 1 2, just give comma to 2020. Okay, and again 2021, 6 1. Now if we give run, you will see more images will be reduced, only 47 images came now. So this is how you filter by date, and this, and now I will just show you, as there are 47 images, so let's just take only one image from that, and I will show you how to. So if we give dot first, it will take first image which is coming. You can, means for just for showing I'm telling you, map to add layer here. So dot first, if you take, it will take only one image. Okay, so I will print you and show you that. Now you see here it is written image, so only one image has been taken now, and that is this image, and we can add this on map. Map dot add layer, I will just copy this for now. Okay, and let's change this, because we don't have anything on data set dot main, so we are just giving image collection here, that we have to give. And here for now we are not giving any color also, just let keep it like that, and this is one image. So I will run like this. It takes time, slowly you will be able to know what is happening. Now whichever image is this, so this was covering two images, so whichever image it is covering has, or I will remove dot first. So some other image will come, then we can see, because a small portion was covered by some other thing, so that image was added. Okay, so this is the image which has been, means which, any one image it has taken from collection, which is the recent one generally, that has been taken, because now we have removed dot first. So all 47 images are there in this stack. uh, we can go to inspector and we can click here. As this is image collection, so just will click and you will see all collection values are coming here. Like, these are the, means on date, which date what was the reflectance that we are able to get here. This I will teach you later, just for showing that all images are there here, because we have not done dot first. So all images are containing here, and we are adding this on map layer. This is just black and white image for now, because I have not given any color. Now in next tutorials I will tell you, means we will be doing this, and then I will teach you something extra, so you will be able to know like what is happening. And if you have any doubt, then we can clear in next session, because and you can try this, so that you will know how this filtering is working on. So that is all for today's session. So uh, you can, if you don't have any doubt, then we can close this session.
Thank you, Nitish.
Thank you.